we've got Spider-Man here with a giant web ball. He's sort of like whipping the web ball around himself, maybe whack a bad guy with it or something like that. And let's say he's throwing this thing around and he's sort of twirling it around at 8.2 meters per second, and he's able to go all the way around himself in about 2.7 seconds. So this would be the period of revolution around him. So what we're going to do is we are going to try and find out how long is the actual web. Well, there's a couple things that we can do here, kind of restricted a little bit with the information that we're given. We don't have the angle or anything like that. Of course, the angle would be really important. So let's see if we can work with what we've got. We've got speed and we've got time. So with speed and time, we can find distance. We can actually find the distance around the circle, which would be kind of nice because then we can find the radius. And the radius is kind of a handy thing to use in circular motion. So if we do that first, speed, basic DTV, distance divided by the period, so speed would be the 2 pi r divided by the period, we can actually find the radius. So if we rearrange this thing a little bit, we can find that the radius is 3.53 meters, give or take a little bit. Now that we have the radius, if we just had the angle, we could find out the length of the web. Now, if you think about what makes the angle in the first place, it's the forces. We've got two main forces going on. We've got the force of gravity, which goes down, and we've got the Fc, which of course goes sideways, which creates the angle. So if we use that force idea, we can actually piece things together. Now, to find the angle, this is the opposite, this is the adjacent, so it makes sense to try and use tan theta. So if we use tan theta, that would be Fg divided by Fc, mg divided by mv squared over r, and the masses cancel out, showing the mass of the web ball has nothing to do with anything. So I've got the radius, I found that. I know the speed, I know g, I know that I can then find my tan theta. So if I rearrange this, do a calculation, I calculate my angle, and should get an angle of around 27 degrees. Well, not only do the forces use that angle, but so do the actual physical dimensions, the length, the radius, all that kind of stuff. So I can actually use that to find out what my length is. The radius is down here, my length is up here, and they share the angle with the forces. So the length would just be the difference between, or not difference, the quotient of the radius divided by cos theta. It's just a triangle. This is the hypotenuse. There's the angle. We're just looking for the adjacent. So we can then take the radius, which is 3.53. We divide it by the cos of 27, and we get a web length of about 4 meters long.